Good day and assalamu alaikum. My name is Jalak Aji Faisal. So for today's video, we are going to discuss surface and subsurface runoff. So first, what is runoff? Runoff occurs when there is more water than land can absorb. The excess liquid flows across the surface of the land into nearby creeks, streams, or pond. Runoff can come from both natural process and human activity. So, ang runoff is nangyayari siya kapag sobra yung tubig and hindi siya kayang i-absorb ng lupa, which is just like what happened recently to Iligan. Nagbaha dahil hindi na kayang i-absorb ng lupa yung tubig dahil mas marami ng sementadong lupa and kunting-kunti na rin yung mga puno natin. So, yes, meron tayong kanal which is dapat dinadaanan ng tubig, pero dahil sa mga human activity na yan, hindi nakakadaan yung tubig ng maayos, kaya nagkakaroon ng baha. So, according to National Geographic Society, the most familiar types of runoff is snowflakes, mountains that cannot absorb water from heavy snowfalls produce runoff that turns into streams, rivers, and lakes. And also, runoff is one of the major reason ng water pollution. As the water runs through the surface, it picks up litters, petroleums, chemicals, fertilizers, and other toxic substances. So there are three major types of runoff, which is surface, subsurface, and base flow. So what is surface and subsurface runoff? Surface runoff, also known as overland, is the water from the rain, snow melting, or other sources that flows over the land surface and is a major component of water cycle. Surface runoff is the water occurs when there is excess meltwater or storm water or other sources that flows over the earth surface. So nangyayari siya dahil masyado nang saturated yung lupa natin to full capacity and hindi na niya kayang i-absorb yung tubig dahil mas mabilis na yung pag-ulan kaysa pag-absorb ng lupa. And also, surface runoff is one of major reason kung bakit nagkakaroon ng mga erosion. So next is subsurface runoff. Subsurface runoff is the water that infiltrates in the vidous zone, unsaturated zone, from rain, snowmelt, or other sources and moves laterally towards the stream. Vidous zone extends from the top of the ground surface to the water table. It is one of the major components in the water cycle. So, ang nangyayari sa subsurface runoff is kapag nagkakaroon ng stored water, yung mga tubig na yan is pupunta siya sa mga lakes or rivers. Then, yung matitira sa tubig na yan is mag-i-infiltrate or magta-travel siya underground, hydrating vidous zone. So, ang vidous zone is a part of the earth between surface land and phreatic at the top of phreatic zone. Next is other parts of runoff. Number 1, base flow or base runoff is the long-term supply of water that keeps at least some water in the stream even during extended dry periods. So ang base flow ay isang base runoff is siya yung long-term supply ng water sa atin, which is kahit extended na yung dry periods, kahit hindi na umuulan, nagtitira pa rin siya ng water in the stream. So number 2 is infiltration. Is the downward movement of water through the soil surface. Whole it is often used interchangeably with percolation. So infiltration is yan yung nangyayari sa subsurface runoffs, which is nag-i-infiltrate, the downward movement yung tubig to the soil surface papunta sa videos zone. So that's all. Thank you.
Good day and Assalamualaikum. My name is Asraf Pisang Kupan Jr., a second-year college with a course of civil engineering. Percolation actually refers to movement of water within soil, and infiltration specifically refers just to the process of water entering a soil surface. Percolation comes from the Latin word percolare, which means to strain through. Percolation happens when liquid is strained through a filter, for example like when someone makes coffee. Infiltration capacity is the upper limit of infiltration rate. It includes surface infiltration and percolation and is expressed in depth per time. For example, 15 millimeters per hour. If precipitation rate is less than or equal to infiltration capacity, no surface runoff occurs. The infiltration capacity of soil is defined as the maximum rate at which it is capable of absorbing water. Infiltration rate is the amount of water able to enter the soil in a specified time period. It is expressed as depth per time. For example, 10 millimeters per hour. Infiltration rate is a measure of how fast water enters the soil, typically expressed in inches per hour for initial in-field assessments. However, it is more practical to express the infiltration rate as the minutes needed for a soil to absorb each inch of water applied to the surface.
Hi and Assalamualaikum warahmatullahi wabarakatuh to each and everyone. My name is Abdul Aziz U. Umar. I am from Group 5. So in this video, I'll be discussing the surface and subsurface runoff phenomenon. So what is a flood prediction? So it can be defined as a process of estimating and predicting the magnitude, timing, and duration of flooding based on known characteristics of a river basin, with the aim to prevent damages to human life, to properties, and to the environment. So when we see flood, nakakatakot to kasi pwede makasira ng bahay, mga taniman, uh, in order to prevent such as damages, we need to find ways and or gather some data to prevent to avoid some possible impact, the possible damages of this flood. So it requires several types of data. So the first one is the amount of rainfall occurring on a real-time basis. So nagbibase din sila sa amount of rainfall kasi doon naman nagsa-start yung pagtaas ng tubig based sa river. Chine-check nila on time para ma-aware yung taong nakapalibot doon sa river. So the second one is the rate of change in the river stage on a real-time basis, which can help indicate the severity and immediacy of the threat. So yun nga, chine-check nila every time yung level ng tubig kasi pag tumas na magkakaroon ng kwan. So may mga sign naman sila, red or yellow. Pero pag red na, yun ang nakakatakot. Pwede na magkaroon ng, for example, typhoon. So the third one is knowledge about the type of storm producing the moisture, such as duration, intensity, and areal extent, which can be valuable for determining the possible severity of the flooding. So yun nga, for example sa pag-asa, binibigyan tayo ng idea kung para maiwasan to prevent para maiwasan, for example, yung gagawin natin pag may paparating na panganib. So what is hydrograph? Hydrograph is a graph showing discharge stream flow at the concentration point versus time. In the beginning, there is only base flow, the groundwater contribution to the stream, gradually depleting and exponential form. After the storm commences, the initial losses like interception and infiltration are met, and then the surface flow begins. The hydrograph gradually rises and reaches its peak value after the time called lag time or basin lag, measured from the centroid of the hydrograph of net rain. So as you can see here in this graph, so this line this is the base flow, which is this is the normal amount of water or the river. So this is the point of rise. So this curve, this is the rising lamp. So when the storm discharge start rising, so this is what we call rising lamp. So this here this point, this is what we called peak flow. So this is the highest amount of the discharge. So this line, this is the falling lamp. So also we as you can see here in the y-axis, this is the time or this. So it could be it can hours or minute, so it depends. So in the y-axis, this is the discharge and rainfall. So also we have a formula here. P net is equals to P minus losses. So this formula i-discuss lang to ng kasamahan kong reporter. So I think that's all. This is the overview of the hydrograph. So if a second storm occurs now, again the hydrograph starts rising till it reaches the new peak and the groundwater recession begins. So as you can see here in the figure, so this is the it's still the x-axis is the time or this in the y-axis is this is the discharge intensity. So this graph, this is the storm 1, this is the storm 2, and this is also the storm 3. So as you can see here, this broken line, this is the estimate base flow. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sadiq Sumdadiran, a part of Group 5 in Hydrology Section B. So for today's video, we're going to discuss the type of hydrograph unit. Types of hydrograph. Unit hydrograph defined as the hydrograph of storm runoff resulting from an isolated runoff of some unit duration occurring uniformly over the entire area of the catchment. Produce a unit volume of 1 cm of runoff. Steps in creating a unit hydrograph is selected from the records isolated, single-peaked, intense storms which occurring uniformly over the catchment have produced flood hydrographs with appreciable runoff less than 1 cm or let's say 8 to 16 cm. Select a flood hydrograph which has resulted from a unit storm chosen in step 1 above. Separate the base flows from the total runoff by the well-known base from separation procedures from the ordinates of the total runoff hydrograph at regular time intervals. Deduct the corresponding ordinates of the base flow to obtain the ordinates of direct runoff. Divide each of the ordinates of direct runoff by the net precipitation debit to obtain the ordinates of the unit hydrograph. Plot the ordinates of the unit hydrograph against time since the beginning of direct runoff. This will give the unit hydrograph for the basin for the duration of the unit storm, producing the flood hydrograph selected in the step 1 above. The derivation of the unit hydrography formula are P net is equals to P negative losses. P net is equals to submission QDT over A, and QD is equals to DRO, and TRO negative BFO is equals to DRO, and DRO over P net is equals to UGO. That's the formula for the unit of the derivation of hydrography. And so where P stands for total runoff and P net stands for net precipitation from heterograph or direct runoff as equivalent debit over the basin. Losses stands due to infiltration, evaporation, and etc. A stands for area of the drainage basin. DRO stands for direct runoff ordinate, and TRO stands for total runoff ordinate, and T stands for time interval between successive direct runoff ordinates, and BFO stands base flow ordinate. And here's are the elements of unit hydrograph base with it, and here are the elements of unit hydrograph base with it, and unit storm, and unit period, and lag time or TP, and lastly recession time. So I think that's all, and I hope you have learned from this video, and thank you, and wassalam.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Moser EEP. Proportion of unit hydrograph. So first is the same run of duration. So in time base with or base period is approximately the same. And the second one is the proportional ordinates. So the ordinates of the hydrograph at any given time are in this are the same proportion as the rainfall intensities. The third one is the principles of superposition. If there is a continuous storm, so they may be divided into unit stores. And lastly, the same distribution percentage, the time base or base width is divided into equal time intervals, percentage of our surface runoff that occurs. Limitation of the unit hydrograph. Certain limitations are inherent in the unit hydrograph theory. The runoff hydrograph reflects the combined effects of rainfall factors, loss factors, and psychographic factors. The design storm continuing for several units periods may not have the same reveal distribution for each time increment. Example number 1. The runoff data at a stream gauging station for a flood are given below. The drainage area is 40 km². The duration of rainfall is 3 hours. Derive the 3-hour unit hydrograph for the basin and plot the same. This is the problem. Here is the data. As you can see, the date, time, the discharge, the remarks, so the time based on R258 and so on, and this is the discharge in every hour. So in the 2, the discharge is 50 centimeter cube over second, and the 5, the discharge is 47 centimeter cube over second. As you can see, the value here start with 50 bumaba then tumaas, then 270 downwards is the falling lump. So 290 is the peak flow. Siya yung pinakamataas, and here is the solution. Unit hydrograph from complex storms involving varying intensities of rain can be obtained by considering the complex storm as successive unit storms of different intensities and the runoff hydrograph. Due to complex storm as the result of the superposition of successive storm hydrograph. Here is the formula. Q1 is equal to XU1 and X2 is equal to XU2 plus YU1. Q3 is equal to XU3 plus YU2 plus ZU1. This is the derivation of the hydrograph. This is the formula kanina with the correspondence of the constant, and this is the rainfall intensities. QE is equal to 2.78 A over TR, whereas QE is constant outflow or centimeter cube over seconds, or the TR is equals to duration of the unit graph or HR. A is equal to area of basin or kilometer squared. For the application of hydrograph from a unit hydrograph of a known duration to obtain changing the duration of UG by S-curve technique. From the unit hydrograph, so the right to obtain the flow of hydrograph corresponding to a significant storms for design purposes, which with the help of unit design flowed hydrograph.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. I am Ismalia Mangkaan Karam. In this part of video, I'm going to discuss all about influence, runoff, and soil properties. So first is influence runoff. During runoff, it might influence the basic slope, roughness, urbanization, and stream density. Of basin slope on a runoff. The slope of basin affects the amount and the timing of runoff. As the slope of the land increases, several factors come into play. The first factors is that the water contact to the surface is no longer perpendicular. And during runoff, naapektuhan yung basin slope. And yung surface is hindi na siya perpendicular. Naiiba na yung shape ng surface because of the increases of water. With the land sloping, gravity no longer pulls the water directly into the ground, so more water is likely to become a surface runoff. Another factor is the movement of water across the land surface. As the ground becomes increasingly steep, water will move faster and will have less time in contact with the ground surface, reducing the time during which it could infiltrate. In general, the steeper the hill slope and the steeper the drainage channels, the quicker the flow response and the higher the peak discharge. The second one is the roughness. Roughness of a stream channel increases due to the presence of rocks, vegetations, and debris. Isa sa mga dahilan kung bakit nagkakaroon ng roughness during runoff, it is because of the presence of rocks and vegetation. Yung mga bato at yung mga halaman. Isa yun sa mga dahilan kung bakit nagkakaroon ng roughness. But the solution of that is by removing the vegetation and lining the stream bed with the concrete, pasesementohan, and it will reduce the roughness. Given the picture is an example of a roughness. By doing removing vegetation and lining the stream bed with the concrete is called channelization. This is also decreases roughness and causes water velocity to increase. The third one is the urbanization. The most important influence on direct runoff change is urban surface change caused by urbanization. Urbanization can cause a large amount of previous surface to turn into a previous surface, changing the hydrologic cycle and reducing infiltration rates. And urbanization typically results in alteration to the natural ground surface and stream channels of a basin, surface permeability, basin size, stream density, roughness, and the channel length and slope can all be affected in a way that results in greater magnitude and speed of runoff. The last one is the stream density. A stream density is the length of all channels within the basin divided by the area of the basin. Stream density is one of the most important characteristics for evaluating potential runoff. A basin with high drainage density, the contribution of surface runoff to stream discharge will be high, while the form-based flow will be low. The next one is the soil properties. There are 4 types of soil properties. First one is the soil texture classification, soil composition, soil profile, and surface properties. The first one is the soil texture classification. The United States Department of Agriculture defines 12 major soil texture classification, which is the sand, loamy sand, sandy loam, loam, silt loam, silt sandy clay loam, silty clay loam, sandy clay, silty clay, and clay. Soil textures are classified by the fraction of sand, silt, and clay in a soil. The 4 hydrologic soil groups are A, B, C, and D, where A's generally have the smallest runoff potential and D is the greatest runoff. In the group A, which is the sand, loamy sand or sandy loam types of soils, it has the low runoff potential and high infiltration rates. In the group B, silt loam or loam, it has a moderate infiltration rate. In group C, sandy clay loam, they have low infiltration rates. In group D, clay loam, silty clay loam, sandy clay, silty clay or clay. In this group, which has the highest runoff potential, they have a very low infiltration rates when thoroughly weighted and consist chiefly of clay soil with a high swelling potential. The third one is the soil composition. The basic components of soil are minerals, organic matter, water, and air. The typical soil consists of approximately 45% mineral, 5% organic matter, and 2 to 30% water, and 2 to 30% air. These percentages are only generalizations at the best. Third one is the soil profiles. A soil profile is divided into layers called horizons. The main soil horizons are A, B, C, and D. Most important for plant growth, the A and B horizons are the top 2 layers of the soil. The A horizon is where there is most soil life and is sometimes called top soil. Depending on the soil, the A horizons can be further divided into A1, A2, or AO, or the organic. And the B horizon is where clays and materials washed down from the A horizons accumulate. This is sometimes called the subsoil. The C horizon consists of withering rock. And the last one, The D horizon is the bed rock. This is the rock which has withered to produce the soil you see above it. The last one is the surface properties. The surface properties is the condition comprises the properties of the surface border zone. These are chemical, mechanical, and the geometrical properties. The chemical and the chemical properties comprise chemical composition, grain, hardness, strength, and inhomogeneities.